Okay, in this section, I'll be talking about how forces applies to the dogs pulling the sled video from seconds 10 to 14. So the first key idea I wanted to talk about is friction. And what friction is, it's the force that resists motion between two objects. And in this case, it would be the sled resisting against the snow. So it's the sled runners sliding over the snow. This is because the snow is smooth and slick, especially compared to like dry ground that usually you would be running across. And so the friction is reduced, making it easier for the sled to move, which makes it go faster. And this is one of the reasons that sledding on snow with dogs pulling you works so well. It's because there's less friction to happen. Now, if the same sled were to be dragged across gravel, then it would have a lot more friction because gravel is very rough and not slippery like ice or snow, which means that the dogs would have to pull a lot harder and with much more force because there's more friction working against them. So here's just a basic, very basic sketch of the sled. So this is a sled, this is the dog attached to it, and this is the dog pulling the sled, and this is the friction working against it because the dog has to run across the slippery slope, but the sled is benefiting from it being slippery. Okay, next I wanted to talk about Newton's second law, which is force equals mass times acceleration. So force equals mass times acceleration. So this law is telling us that the acceleration of the object depends on the mass and the total net force of acting on it. And in the sledding in the video, the dogs apply the force to the sled and it causes it to accelerate forward. So force on the sled moving forward. Let's say that these are the sleds. And if there was less mass in the sled, then the dogs would move a lot faster. But if there was more total net, it would become slower because the force would be harder to exert from the dogs, which means they would have to pull harder. But if they pulled harder, then it would accelerate faster because of the mass. Okay, now time for the guess equation. And so what we're given here is the sled and rider have a combined mass of 150 kilograms, and the net force from the dogs pulling is 300 newtons. What is the acceleration of the sled? So what we're given here is the mass is equal to 150 kilograms, net force is equal to 300 newtons. Our unknowns are acceleration. Our equation is Newton's law, F equals ma, which equals mass times acceleration. Substitution is 300 equals 50 times a, so that's our net force equals our mass times acceleration, which we don't know yet. Solution is a equals 300 plus 150 equals 2. So then the statement would be the acceleration of the sled is 2 meters a second squared. To sum up, the dog sledding scene is, a great example of how physics is in the real world around us. We can see the friction with the snow helping reduce resistance so the sled glides easily. And we can see how Newton's second law plays out with the force of the dogs causes the sled to speed up depending on its mass. And then here we use real enough numbers to calculate the speed of this sled's acceleration, which helped show it in a real life scenario. Okay, now I'm going to move on to kinematics. Okay, so the first concept I'm going to be talking about is speed versus velocity. And so the difference between speed and velocity is if these two objects are moving this and this, same speed, same everything, 75 miles an hour, 75 miles an hour. So that's the speed of it. But the actual velocity of it would be 75 miles an hour east. Yeah. And so it includes both the speed and direction of the object. And the sled, so let's say the sled is moving at 6 meters a second and across the snow, so that is its speed. But if it's moving west, so it would be 6 meters a second west. But if it was moving north, then it would just be north, south, south. But this is the speed, this is the velocity. And velocity is actually a vector, so it has a magnitude and direction, while speed, it's just a number, so that's big difference from it. Okay, so the second concept I'm going to be saying for kinematics is acceleration, which is change in velocity over time. So that could mean that the sled is speeding up, so it's going faster and faster and faster, or it's slowing down, or changing direction, or anything. In the video, when the dogs are running for the first time, and the only time, the sled goes from rest to moving speed, and even though it looks smooth, the initial push involves a force that increases the sled's velocity. So let's imagine the sled goes from 0 to 6 meters a second in 5 seconds. That is a good setup for what I'm about to do. Okay, the question I have for the guests is, a dog sled starts from 0 meters a second and reaches its velocity of 6 meters a second in 5 seconds. What is the sled's acceleration? So what we're given is the initial velocity is equal to 0.0 meters a second. Final velocity is equal to 6.0 meters a second. And the time it takes it is 5 seconds. Okay. Now the unknowns is the acceleration, which is what we're looking to find out. And the equation we're going to use is A equals final velocity minus initial velocity divided by time. Okay. So now the substitution is obviously A equals 6.0 minus 0.0 divided by 5. And now the solution, 6.0 equals 1.2. Okay, so that is the final acceleration. So the sled's acceleration is 1.2 meters a second squared. And that's basically it for kinematics. We looked at how velocity describes speed and and direction, and speed is just the speed of it, and it's important for tracking the sled's motion across the snowy field. We talked about acceleration, which helps how the sled gets moving from 0 to 6 meters a second, and by calculating the acceleration from a realistic enough situation, we can see how physics equations they actually work in real life, and they can actually like describe real life situations, like this dog sled in the park.